Okay, guys. Recap. What have we done on an example 4? So we still have just a smidge to finish up on this one. So we had our given function, f of x, and we were given a point. Note, we haven't used that point yet, have we? Okay, we're getting ready to do that next. But it asks us to use the difference quotient. The difference quotient being that right there. Okay, so we did that by finding f of a plus h and f of a. We went through all the stuff. General rule of thumb with these is you're going to get terms to cancel on top to where everything left has an h. You can factor the h out and cancel the h top and bottom. That's general rule of thumb, what will usually happen. Okay, so then the limit as h approaches 0, means we put 0 in for h, and we are left with the formula m equals 2a. And so that m equals 2a, that is representing the slope of the line at any point on this curve. So this is, let's see, how do I have it written in my notes? It's a slope formula for any value of x on the equation y equals x squared. So I'm going to write that down. Slope formula for any value of x on y equals x squared. Now, we were asked to talk about this at the point 39, yes? So when we start talking about at the point 39, keep in mind 3 is your x value. It's also, if we talk in terms of a, it is your a value, and 9 is your y value, or your f of a value, if you will. Okay, so with that in mind, two different thoughts here. First of all, in this place, since a is 3, each of these places where there was a, we could have had those as 3s. Okay, obviously we didn't, but we could have had these, I guess not right up there really, because that's the original formula. But each of these places, we could have put in 3s. Okay, with that in mind, what do we end up with? If a is 3, then my slope is going to be what? 2 times 3 is 6. Okay. By us just leaving it as a plus h in there, we were able to find just a general slope formula. We could have also had 3 in there from the beginning and worked with 3. And we would have gotten to our answer of 6 also. I don't know if it helps or not, but in terms of a graph, what's happening is this was y equals x squared, right? So if you think about y equals x squared being this graph, I'm picking this point to be the point 39. 6 is the slope of the tangent line. Well, where's our tangent line? Well, my line's not very straight, but that's the idea that that's the slope of the tangent line. Okay, and that's what we were trying to find. That's what that 6 is there. Okay? Does that kind of tie everything up from yesterday? We stopped in an awkward place on that one, but I want to tie it back together. And we are going to, if I recall correctly, get more practice with this difference quotient today. So, okay, moving on. Writing equations of tangent lines. Remember that writing the equation of a line requires a point and a slope. It follows that we should be able to write an equation for the tangent line through a given point since we can find the slope by the limit process, and we are given either a point or an x-coordinate. In calculus, we will focus on using point-slope form of a line, and notice y equals m times x minus x1 plus y1. This is not exactly how you've used this in the past, right? In the past, this is coming from, you guys are used to seeing y minus y1 equals m times x minus x1. If I write that, does that seem familiar? Where it was the y minus the y point equals the slope times x minus the x point. Yes? Okay. Here's the deal. On calculus, if you have to write the equation of a line, I don't think they're ever going to tell you the equation of the line in this form. You just write it. So whether it be something like slope-intercept or point-slope, this is a common variation of this line over here. And what did they do? All they've done is take the y1 and add it to the other side. Okay, so it's a common variation. Become familiar with it. Okay, that's all that I would ask. Okay, so example 5 real quick. Write the equation of the tangent line for y equals x squared at the point 3, 9. Well, we already have all the information we need here. They gave us the point. What else do we need to write the equation of the tangent line? The slope. What do we know about the slope? It's 6 because isn't this the same information from example 4 up above?
Yeah.
Fair enough. I'm not making magic happen. We already found it to be 6. So write the equation of the tangent line. If we're using their form, instead of saying y, what would you guys normally say? You would normally say y minus what? 9. So hold that minus 9 in your head. So y equals m, which is 6, parentheses, what's in my parentheses? X minus 3. And then it would have been a minus 9 on the other side. What are we going to put over here outside the parentheses? A plus 9. That's all it is. It's just that number moved over. So, whether I use that form, whether she uses that form, just realize if you go back to the old form, which it's going to happen sometimes, realize that that's the equivalence. Okay? Okay, continuing along. Since the slope of a tangent line is a limit, this would be a good place to discuss what happens when limits fail to exist. The slope of the tangent line might not exist because the limit doesn't exist. So like our asymptotes, our holes, or not. The asymptotes, a discontinuity of some sort, an oscillating function, or because the tangent line has a vertical slope. In the case that a tangent line that exists but has an undefined slope, so vertical tangent line, we use the following definition. And so this is just your definition of the limit we already talked about, right? Limit as h approaches 0 of f of a plus h minus f of a all over h is equal to either positive or negative infinity. And then that's saying that if you get a positive or negative infinity, that your tangent line is a vertical tangent line. Okay, because remember, horizontal lines have a 0 slope. Vertical lines, that's dividing by 0. They have an undefined slope. Okay, and so that's when your limit will work out to equal the positive or negative infinity. So, in reference to, of course I can't write right there. We'll do it like that. Okay, in reference to that, like right there, remember that's when you do a number divided by 0. Okay, that's what you're having, you're having happen as your slope. Okay. Okay. Top of the next page. New vocabulary word. I don't think we had this in pre-calc.
No.
Maybe we did. Normal line?
No.
Okay. Normal line. It's a new word for something you've known for years. The normal line to a curve at a point is the line perpendicular. So when we talk about the normal line, that's the calculus way of saying perpendicular.
Why can't they just say
I don't know. I don't ever remember learning the normal line, the vocabulary normal line. I mean, honestly don't remember my high school calculus. I don't really remember using normal line in college though either. So, okay, so the normal line to a curve at a point is the line perpendicular to the tangent line at the point. So you see in the diagram right here, here's your tangent line. The normal line is the one that is perpendicular. Remember, perpendicular means meeting it at a right angle. Not just crossing it, but specifically meeting it at a right angle. To find the slope of the normal line, use the opposite reciprocal of the slope of the tangent line. So remember, parallel lines have the same slope. Perpendicular lines are opposite reciprocal slopes. I just reviewed that in pre-calc last chapter, so you reviewed it about a year ago with me. Not saying you remembered it, but let's see. So perpendicular, another word. I know I introduced this one in pre-calc. Do you remember the word orthogonal?
Yeah.
Okay, which orthogonal is also another word for perpendicular, right? Okay, so normal line, perpendicular, orthogonal, all the same thing. In terms of notation, I think I introduced this last year. Maybe I didn't, but an upside down capital T, that is a symbol for perpendicular. All of this valid stuff you could see. Okay, so let's see. The only other thing, so let's see. Right angle. When we talk about opposite reciprocal, the idea is that if you multiply two slopes, when you multiply opposite reciprocals, so a positive times a negative will be a negative, and reciprocals always multiply to equal 1. So opposite reciprocals would multiply to equal -1. That's just something that we often think about. Okay? Vocabulary information. I'm ready to look at example 6. Have some fun with this. Okay, maybe fun isn't the right word for example 6, but okay. So 6. This would be better if f of x was a little bit easier equation, but that's all right. We're going to test ourselves. F of x is 1 over x plus 3. First of all, it's asked us to use the limit definition to compute the slope of the tangent line at x equal a. So in other words, for any value x. So, remember our limit definition from the previous side? The slope is going to be the limit as h approaches 0 of f of a plus h minus f of a all over h. That's what we're filling in, right? So, m equals the limit as h approaches 0. What is f of a plus h going to look like?
One over a plus h.
Yes. Every place I see an x, I'm replacing with a plus h. So 1 over x plus 3 is 1 over a plus h plus 3. Now, the a plus h could be in parentheses, yes. They don't have to be here because we're just adding 3. Minus f of a. What's f of a look like? Every place I see an x, I'm putting a. So 1 over a plus 3. All over h. Okay. Fun stuff here? Now, here's the deal. We have to do something with that mess, so to speak. I'm not speaking very nicely of it, am I? So, it's still going to be the limit as h approaches 0. Some ways to handle this, because here's the idea. I said that once you got everything to cancel out on top, you end up with usually an h in everything that can cancel. Well, right now, my top is 2 separate fractions, right? How can I put those 2 fractions together? Okay. Get a common denominator. What's going to be the common denominator there?
H.
A plus h plus 3.
Not just a plus h plus 3.
Plus those, you do
You're going to have both of them. Okay?
cancel roots.
Yeah, you're going to have both of these. You're going to have the a plus h plus 3 and the a plus 3. Because they are added pieces, you can't just do part. Okay? Okay, how do I want to do this? First of all, to make this a little less chaotic, this is all divided by h, yes? So one time, this is like one thing, dividing by h is the same thing as multiplying by 1 over h. So I'm going to take that h that's divided by, and I'm going to put it out front here, so it's just kind of out of my way. Okay, and just making it less chaotic. Now, the deal is to make these 2 fractions into 1 fraction. We said the common denominator is going to be a plus h plus 3, that quantity times the quantity a plus 3. Are you with me there? First fraction. It already has a plus h plus 3 in the denominator, so what do I have to multiply it by? A plus 3. So what do I multiply the numerator by? A plus 3. That's the first fraction. Then I'm going to carry down my minus sign. The second fraction. It has the a plus 3. What's it missing? A plus h plus 3. So officially you multiply the bottom by a plus h plus 3 and the top by a plus h plus 3. So then it's 1 times a plus h plus 3, which is, I'm going to write minus the quantity a plus h plus 3. Or if you prefer, you could have written minus a minus h minus 3. Right? Okay. Are you with me? Yes? No? Okay. So I know that wasn't fun, but okay, let's go down. Next step, limit as h approaches 0. My 1 over h out front is hanging out there. My denominator is going to hang out the way it is for right now. A plus h plus 3 times a plus 3. What about my numerator?
A's and 3 cancel. That's just H.
Can you guys get on board with Tate? The a's and 3's cancel? Because it's going to end up being a minus a and 3 minus 3, which means what's left on top?
H. Negative H. Wait, yes.
I agree with Augie. Are you guys with him? Negative h? because you were subtracting h, yes? Now, what I said would happen happened. A bunch of stuff on top canceled. Normally there's more than one term on top, but hey, we'll take it. What can happen now? This h on bottom can cancel with this h on top, leaving me with what? The -1, yes? Okay, so let me write this out. The limit as h approaches 0 of -1 over a plus h plus 3 times a plus 3. Okay, I've dropped off my m equals. These were all slopes, right? So what's going on here? What do we do next?
Can we plug in the 0?
We're ready to take the limit now, because we're now at the point where we're not going to get 0 over 0. And how do we take the limit as h approaches 0? We plug in 0. There's only one h though, isn't there? So if you plug in 0 for that, we end up with a slope of what? -1 over,
A plus 3 squared.
it ends up being a plus 0 plus 3, which is a plus 3, times another a plus 3. Could I write it as a plus 3 squared? I can. Okay, so this right here is my slope formula. Okay, this is the slope of the tangent line at x equals a. So at any x value, you can use this to find the slope of the tangent line for this equation here. Got it? Now, B, C, D, and E all go along with this, if I recall. What's B ask us to do? Find the slope of the curve at x equals -1. So what am I doing?
Plugging in -1 to a.
Plug in -1 for a. Exactly. So this is going to be my a value. So it was what? -1 over a plus 3 squared. So -1 plus 3 squared. Do some math, and what do we get? -1/4. Okay. C, write the equation of the tangent line to the curve at x equals -1. What do we need to write the equation of a tangent line? What do we need to write a line? A point and a slope. What do we know?
Slope and half point.
Okay, good answer. We know the slope is -1/4. And Aiden says we know half a point because what do we know? -1 comma something. How do I find the other half the point?
That line equation.
Okay, go back. What was the original equation we're working with on this problem? It was f of x equals, what is it, 1 over x plus 3? Can we use that right there to find our y value? Just go back to the original equation is what we're saying. So y equals 1 over -1 plus 3, which is 1/2. Because you're going back into not the slope equation, but we're going back into the original f of x for this problem. Okay, and what they want us? An equation of the tangent line. So, y, we're going to go the modified point slope form. So y equals I need my
Negative
slope, which is negative 1/4,
x plus 1
x minus negative 1, okay?
plus
And then what?
plus
Wait, would it be minus 1? Because wait, no, it's plus because it'd be because it's minus 1.
Right. So normally it would be y minus the value over here. So if it's y minus 1/2, we would have to add it to this side. Just like here, it's x minus negative 1. And so that's what changed the sign here. But I'll be honest, for a moment, I don't know if you guys saw it, I had to stop and think because I got confused for a moment. I was trying to process. I don't know who's right. Okay. Not too bad, right? D. Write the equation of the normal line to the curve at x equals negative 1.
the opposite of slope.
Okay, the key is to get the new slope. Originally, our slope was negative 1/4, but we need our normal slope. And what's our normal slope then? Opposite, reciprocal.
Positive 4.
Opposite of negative is positive. Reciprocal of 1/4 is 4/1. So we have our normal slope, and did my point change? No, you're still going to use the negative 1, 1/2. Basically, take the equation from the previous one and change the slope from negative 1/4 to 4. So 4 times x plus 1 plus 1/2. Okay. Use the equation from C to estimate the value of x equals negative 1.1. Okay, what was our equation from C? This guy right here, yes. I'm going to write it as f of negative 1.1 because we're plugging in negative 1.1, yes. Now, negative 1/4. 1.1 is a decimal, yes? You should probably either go all decimals or all fractions. Doesn't really matter which, but if we're trying to do this without a calculator, which I'm going to encourage you to do here, I'm thinking decimals might be a little bit better. What is negative 1/4? Negative 0.25 times x, which what are we putting in for x? Negative 1.1 plus 1 in parentheses, and plus 1/2 is plus 0.5. Okay, guys. This is doable without a calculator. Let's see. Negative 1.1 plus 1. What?
Negative 0.1.
Negative 0.1. So then I'm doing negative 0.25 times negative 0.1. Well, if you remove decimals, 25 times 1 is 25, right? And then how many numbers after the decimal do we need? 3. So this is going to be 0.025, if you will. A negative times a negative is a positive. 0.025 plus 0.5 is 0.525. Okay, real quick, I'm not going to turn the page quite yet. It doesn't ask this here, but I think I have it in my notes because it asks it in homework, is what I'm going with. And that is talking about the idea, we estimated this, okay? And talking about the idea, is it an underestimate or an overestimate? And knowing just the idea, and here's what I'm going to do. I'm going to sketch a graph, okay? If we're going back to the original function, which was 1 over x plus 3. Well, do you guys remember 1 over x? We talked about this graph. 1 over x is the two curves going out from each other. X plus 3 says we take that graph and move it left 3. So my graph does something like this. Okay? Like that's just what the graph looks like. And you could get that on the calculator. Now, originally, we are talking about -1, and we're trying to estimate it for -1.1, right? So here at -1, here's the point at -1, yes? That's -1. Where is -1.1 in relation to that? -1.1 is technically just slightly past it, yes? So with that in mind, okay, we're using the idea that the tangent line at -1, because that's what we originally wrote, isn't it? The tangent line at -1, I want to talk about this -1.1 that we used. Okay. Is it going to be an overestimate or underestimate? Something's not jiving in my mind. Underestimate or overestimate? What am I doing wrong? Okay. Okay, my brain is not computing something. Because my brain wants to go with you guys, because you guys, I just heard overestimate, because, and the answer is underestimate. Why? Oh.
Because it has a downward slope.
It's an underestimate because it's underneath the curve. That's what it is. Okay, my brain, and this is, sorry, I had a moment of, I couldn't remember. My brain was going with, you guys were saying overestimate because it's a higher point, yes? But here's the idea. and I'm going to prove it to you. When my tangent line lays under the curve, your estimate's always going to be an underestimate. If my tangent line was able to lay above the curve, basically if my curve went the other way, that's going to be an overestimate. Now, proof. Okay, this was using negative 1.1, right? And this was estimating. If we go into the original piece right here, okay, if we go into the original piece and find f of negative 1.1, it's 1 over negative 1.1 plus 3. Obviously, that's more of a calculator type problem at that point, or just, not something I'm going to take the time to do, but it actually works out to be 0.526. Your calculator would back me up on that, okay? 0.526, well, that makes this guy an underestimate. And it's an estimate. So it's not supposed to be exact, but it's an underestimate. Reason it's an underestimate because the tangent line is under the curve. Okay, so if you want to write that reminder down, gosh darn it. Obviously, I need to put a reminder in my notes because I spaced on that one. Okay. One last page. Okay. Given the graph of the function f of x equals 4x minus x squared, shown at the right, determine how fast is the graph changing at x equals 1. That is, what is the slope of the tangent line at x equals 1? Okay. Now, we're going to take this through in pieces. We have a couple of different things we're going to talk about. But here's x equals 1, right? Hey, there's words you don't see very often. Use your calculator. I promise we do use the calculators this year, okay? Just not a whole lot at the beginning, but use your calculator to evaluate the average rate of change. Did you guys catch that? Average rate of change, which is average rate of change, AROC, or slope of the secant line, between the point 1 and f of 1 and 1.001 and f of 1.001. Be sure to show the difference quotient, which the difference quotient is just what they're looking for right here is the f of b minus f of a over b minus a. So f of, I would start with the 1.001 minus f of 1 all over 1.001 minus 1. Okay? Need to calculate for anything else? If you want, you guys remember how I showed you that? So, if I type this equation in here, 4x minus x squared, I just typed it into y5. Remember that. So then I could come here instead of a fraction. If I go into alphas at f4, yeah, it was y5 of 1.001 in parentheses minus alpha f5 y of 1, so 1.001 minus 1. Okay, there's the calculator. So that right there is your slope of the secant line. Now keep in mind it's slope of the secant line because here's 1 1.001 is where? Essentially right next to it, isn't it? So when we're talking about that slope, or AROC, okay, whether you want to say slope of the secant line or AROC being 1.99, we're talking about that right there. Okay? So, keep in mind that number 1.999. Okay, B. Find the average rate of change between the points 1 and f of 1 and 1 plus h and f of 1 plus h. Officially again, average rate of change means we are talking AROC, or slope of the secant line, if you will. Okay. Officially, we're doing what? F of 1 plus h minus f of 1 over 1 plus h minus 1. F of 1 plus h. What is f, folks? F is that, right? So f of 1 plus h. Every place I see n x, I'm replacing with 1 plus h. So 4x is going to be 4 times 1 plus h minus x squared. Means I'm going to be subtracting 1 plus h squared. Are you guys with me on that? So that's f of 1 plus h. And then we have to say what? Minus f of 1. So f of 1, every place we see x, we plug in 1. So that's just doing what? 4 times 1 minus 1 squared, whatever that math works out to be. Notice I did put minus and I put the whole thing in just one big parenthesis because it's going to be minus whatever that value is. The denominator? 1 plus h minus 1. Are you guys okay with everything I just did? Ask if not. Okay, let's do some cleanup. 4 times 1 plus h is 4 plus 4h minus, okay guys, what am I doing with 1 plus h quantity squared? FOIL, right? Okay, write it out if you need to. Do it in your head, whatever. First, 1 times 1 is going to be 1. If we go ahead and apply that minus as we go, it's minus 1. Outsides and insides. Outsides, 1 plus h, so 1h. Insides, 1 times h, 1h. 1h and 1h is 2h, but we are subtracting. Last, h times h squared, but we are subtracting. And then minus whatever that f of 1 was. Minus 3. 4 minus 1 squared. All over what? And if you want to go ahead and clean it up, 1 plus h minus h is just going to be h. Okay. Is there some good stuff happening on top? What do you see happening?
3h
Divided by 2.
Okay, so I heard 4h minus 2h is going to be 2h.
Y minus
What's happening with 4 minus 1 minus 3? 4 minus 1 is 3, minus another 3. Those guys just cancel each other out. So we end up with 2h minus h squared all over h.
does the h squared the h cancel?
So basically a single h cancels out of everything.
Oh.
Okay, good form is I'm going to factor the h out on top. So if I factor the h out on top, then I'm left with 2 minus h in parentheses over h. And now you officially cancel the h. Does that make sense? So now this just becomes 2 minus h. So the slope of the secant line, or in other words, A rock, which is what they ask us to find, is 2 minus h. Okay. Oh, I do have on here, that is as long as h does not equal 0. And I think that's just because h was originally in the denominator as 0. So, or I mean, h was in the denominator by itself and it can't be 0. Okay. So that is your average rate of change. 2 minus h. C. Remember that because we have to use it on the next part if I recall. What happens to the secant lines between the points 1 and 1 plus h as h goes to 0? So basically, take the limit of what we just found. Okay? When we're asking what happens to the secant lines, we're looking at the limit as h approaches 0 of what we just found, that A rock, 2 minus h. What happens when you plug 0 in here? You get a slope of 2, yes? Okay, so as that h is approaching 0, your slope is getting closer and closer to 2. And if you go back to part A, we originally found 1.999, right? And so the more zeros you put in there, the more 9s you're going to get. Okay, D. Find a general formula for finding the slope of the tangent line at any point by using the points x and f of x and x plus h and f of x plus h. Now, this is going back to using our limit. So, what do I want to say here? The slope of the tangent line is that limit as h approaches 0 of, what is it, f of x plus h minus f of x all over h. What they're asking us to do and that's, okay, so they're asking us to do this for, what was my original equation? It was that y equals 4x minus x squared, right? So they're asking us to do it for that equation. Okay, so finding just a general formula that can be used for any point. We talked about using 2 at the beginning, or excuse me, 1, but so we can use it for any point. Which, this is going to be similar to what we did in part B. but we have the x plus h instead of 1 plus h. So, the limit as h approaches 0. Okay, f of x plus h again. Can you kind of just copy from part B? Because this is very similar to what we just did here, right? Except instead of 1 plus h, I'm now using x plus h. So f of x plus h. 4 times x, so instead of x, we're going to say 4 times x plus h minus, instead of x squared, it's going to be x plus h squared. So that's the f of x plus h minus f of x. Well, what is f of x? That equation right there. I should have written it as f of x equals. So I'm going to say minus, I'm going to put in parentheses the quantity, 4x minus x squared, all over h. The limit as h approaches 0. Distribute 4x plus 4h minus, when you do the x plus h squared, remember, it's minus x squared. X times h is xh, plus another xh is going to be 2xh, and we're going to subtract it. And we're subtracting the minus h squared. Distribute the minus on this last part, so minus 4x and plus x squared all over h. Okay, numerator. Four x's cancel and x squareds cancel. So I have the limit as h approaches 0 of 4h minus 2xh minus h squared all over h. And what's happening as you would expect? Everything on top has an h, so I'm going to factor an h out. H times 4 minus 2x minus h all over h. The factor of h cancels. So this is the limit as h approaches 0 of 4 minus 2x minus h. You'll notice I've written that word limit every time, haven't I? It gets annoying, but have I taken the limit yet? No. And if you drop it off, you will forget, guaranteed. Am I ready to take the limit now? Yes. Since it says h approaches 0, we're going to plug in 0 for h, and what do we end up with? 4 minus 2x. So this right here is the slope of the tangent line is 4 minus 2x. Okay, that's your general slope for the tangent line. Any tangent line to that equation would follow this formula. Okay, we made it. Thought we'd made it sooner than that, but okay. I don't know if you've glanced at the homework or not. There is some estimating in here that you kind of have to do. So you might want to have a ruler by your side when you do this homework, because 3 through 6, they do ask you to sketch the tangent line and then use a straight edge and then estimate the slope of the tangent line. To estimate the slope of the tangent line, just using slope, y minus y over x minus x. Our answers are not going to all be identical there. Okay?
So we do that for the point A?
Yes, for the point they give you there. Yep. So, And then you've got some difference quotient work to do. They're going to make you work on that. Bring back questions tomorrow.